Hello everyone, welcome to my channel. Today we will discuss Leetcode question number 207, which is course schedule. So let's read the question. So there are total of num courses you have to take level from 0 to num courses minus 1. You are given an array prerequisites where prerequisites I equal to AI of BI, AI and BI indicates that you must take course BI first if you want to take course AI. Okay, so for example, the pair 01 indicate that to take course 0, you have to take course 1 first. Means you will be given uh, a vector of a vector called prerequisite that will contain a list which will have two elements where the first element and the second element are the courses, and they indicate that to take the course, suppose 01 is given, so if you want to take this course, then you need to complete this course first. So uh, take yeah to take course 0, you have to first take course 1, and you have to return true if you can finish all courses, otherwise return false. So you have to return true if you are able to complete all the courses. Otherwise, you have to return false. And you will be also given number of courses. So let's see one example test case. So it is the same example that is about. So 1 0. So if you want to take this course 0, uh, sorry, if you want to take this course 1, then you need to complete this course 0. So there are total of two courses, and course 1 you should have finished course 0. Okay, so it is possible. You can complete all the courses. Now, let's see the second test case, which is 1 0 and 0 1. So here also there are total two courses. Okay, and you can't complete any of the courses because it is saying that this one is saying if you want to take this course, then sorry, if you want to take this course, then you have finished this course 0. Okay. And second one is saying that key, if you want to uh, if you want to take you have finished 0 possible. So it's okay. So if you have to take this course 1, you need to complete this course 0. And if you want to take course 1, then you need to complete this 0. Let me check if I'm correct or not. To take course 1, you should have finished course 0. Okay. And course 0. Yeah, if you want to take this course, you should have finished 1. So these are opposing each other. Means the first one is telling ki if you want to take course 1, you need to complete 0. And the second one is telling that ki if you want to take course 0, then you need to have first completed 1. So these are opposing each other. So you won't be able to complete any course. Okay, so so now let's discuss the approach. So this question is of graph. You can solve it using graph. If you see this example, it is given 1 and 0. And it is telling ki if you want to take course 1, you should have completed 0. Okay, so we can draw an arrow like this. Ki course 1 is dependent on 0. If I want to take course 1, then I have to complete 0. And other one is saying that if I want to take course 0, then I should have previously completed 1. Means arrow should be like this. Means I should have completed 1, then only I can take the course 0. So it is forming a cycle. Okay, so in this case it is not possible. Seeing the example 1, so it is 1 0 1 0, and if I want to take course 1, I need to complete 0. So arrow will be something like this. Once I have completed 0, then only I can take 1. Okay, so how we can solve this? We can think of topological sort. We can use topological sort here. Okay, so uh, the, what you will do, whatever edges you have been given, and you will create a graph out of that, and also you will calculate in degree for the edges. Okay, so for this, graph will be like this, 0 1, and arrow should be like this. It will be a directed graph. So if you have completed the course 0, then only you can take 1. That's why arrow is from 0 to 1. And you will also calculate the in degree. So in this case, in degree for 0 will be 0, and in degree for 1 will be 1. And in topological sort, what we do, we start with the node which is having 0 in degree. So, um, and so 0 is having 0 in degree, so we will start with the 0. And whatever node will be adjacent to that 0, we will reduce the in degree, and we will add that node to our queue. Okay, so 0, we will remove this. So 0 will also have in degree 0. Uh, yeah, so we will add this to the queue. And in this way, we can get our result. So let's discuss it on some bigger example. So I will take one example. Uh, 3 comma 0, 3 comma 1, and 3 comma 2, 4 comma 3, 4 comma 3, and another one will be 5 comma 4, 4 comma 4. Okay, so let's discuss in this example. So what we will do, we will create a graph of these edges, and along with we will calculate the in degree of the nodes. Okay, so it is 3 0. So arrow will be going from 0, uh, 0 to 3. Okay, another one is 3 1. Let's add a arrow. It is telling that key before taking course 3, you need to complete 0. So 3 is dependent on 0. So that's why arrow from 0 to 3. Another is 3 1. So 1 is the course and it is dependent on 3. Another is 3 2. So 2 is the course dependent on 3. Okay, along with we will calculate the in degree. Okay, we have total of 5 nodes. So, 6 nodes. That's 0, 1, 2, 3, 4, and 5. So, till now, 0 is having 0, 1 is having 0, 2 is having 0 in degree, and 3 is having 3. Okay, another is 4, 3. So arrow will be going from 3 to 4. And another is 5, 4. So 5 will be here. Okay, and we will also have our in degree. So 4 is having 1 and 5 is having 1. Okay, so we are ready with our graph and in degree of the nodes. So in topological sort, we start with the nodes which is having 0 in degree. So 0, 1 and 2 are having 0 in degree. So we will also have a queue. And in that queue, what we will do, we will push all the nodes that is having 0 in degree. So 0, you will have 0, 1, and 2. Now we will take out 0 from the queue and we will explore all the nodes adjacent to 0. So 0 is having 3. So I will reduce the degree of 3. So it will become 2. And we will check whether the degree of 3 is 0 or not. If it will be 0, then only then we will add it to the queue. Otherwise we will not. Okay. So no other nodes are adjacent to 0, so it is over. We will take out another, which is 1, and we'll explore all the adjacent nodes, which is 3. So again, we will reduce the degree of 3 by 1. So degree of 3 will become 1, and it is also processed. Another is 2. So we'll take out 2 and check the adjacent nodes of 2. So 3 adjacent to it. So we'll decrease the degree. Now we can see degree of 3 has become 0. So we will add this to our queue. Okay. And whenever we are removing a node, we will we will keep a count variable. We will keep a count variable. So we have process node 0. So one node is over. So we will increase our count. So in total we have process 3 nodes. So till now count value will be 3. Now we are going to process 3. So we will take out this 3. We will increase our count. Count will become 4. And we'll check all the adjacent node to 3. So 4 is adjacent to it. Will decrease the degree of 4. It will become 0. Now we will check whether 4 in degree is 0. Yes, it is 0. Then we will add it to the queue. And we have processed this 3. Now again, we will take out this 4 from the queue and increase our count. It will become 5. 4. Yeah. So we will check all the adjacent node to 4. So which is 5. So we'll decrease the degree of 5 by 1. So it will become 0. Now integer of 5 is 0, so we will add this to the queue. Now we have processed this 4. Now we will take out this 5 from the queue and we'll increase the count and we'll explore all the nodes adjacent to 5, but no nodes are there. So our iteration is over. And at the end, what I will do, I will check whether this count is equal to the number of cores that we are given. If it is equal, then it is correct. It is showing the total number of courses that I was able to take. If it is not equal to number of courses, then in that case we will return false because we are not able to take all the courses. Okay, so this is our logic. So let's see the code. So I have taken a vector of vector for graph with size number of courses and also taken a vector for in degree. And I'm traversing the prerequisites and pushing it into the graph and also calculating the in degree. And after that, I have taken a queue and I'm iterating the in degree vector and checking which node is having 0 in degree. Whichever is having 0 in degree, I'm pushing it into the queue. And after that, I am it iterating over the queue and also taken a count variable, and I'm running a while loop till the queue is not empty. Taken a n for the size of the queue, whatever element is present, and running a loop n times. And if I'm able to process that node, I'm counting that. This for if I'm inside the for loop, that it means that I'm processing that node. So I am counting that also, and I'm taking one element from the queue and popping them out. And after that, I'm exploring all the adjacent edges to that node and decreasing the in degree of that node and checking whether the in degree of that node is 0. If it is 0, then I'm pushing it into the queue. And at the end, I'm checking whether I was able to complete all the courses or not. So if count will be equal to number of courses, then it will return true. And if it will be not equal, then it will return false. So let's run our code. Now, okay, so let's remove this. Now submit it. Yeah, it passed all the given test cases. So now time complexity for this code is it will be similar to topological sort, and it is also a graph. So we are just traversing a graph. So time complexity will be similar to graphs BFS traversal, which is uh, of E plus V. So that's it. Thank you for watching. Do like, share, and subscribe.